Hey everyone, today I'll be going over an easy Leetcode problem, 637, average of levels in binary tree. So all this means is go level by level, get the average, right? So average of the first one, there's 1, so it's 3, we can see in the output. Average of these is 14.5, average of these is 11. So when we're going level by level, it screams that you should be using BFS because that's exactly what BFS is used for. I'll cover it a little bit in this video. But, and yeah, this is the definition of a binary tree, val, left and right, you know the drill. Let's go like this, and then go up, and then get rid of that. So, the first thing we want to do is set up our result. We know we want a list of double, and this list is just like the zero indexed averages of each level, right? So at the zero index, it's the 0th level, blah, blah, blah. So we have our res, set it up as a new array list. When we're using BFS, iterative, we know we use a queue, so let's set that up as well. And we'll have this be filled with tree nodes, queue equals new linked lists, just using that as a queue. Another thing that we need is, okay, let's look here. Okay, another thing that we will need is we'll need to put this root in the queue because it's the very first one that we need to explore. And I'll go queue.addRoot, and let's just make sure that this can't be null. Let's see here, the number of nodes in the tree is in the range 1 to 10 to the 4. Okay, so there's going to be at least 1. So we can add it. We know it's not going to be null. Now let's go while the queue is not empty. So I'll just go while queue size is greater than 0. While there's still some nodes to explore, we know we're going to return this res at the end here. Okay, so the next thing we're going to do is we have to get the size of this current level. Now the current level is simple. It's just all the nodes in the queue because that's what BFS is, right? You put all the nodes in the queue. You consume them, and then you get all of those nodes and put their children in. So you put 3 in, you get rid of it, you put 9 and 20 in, 9 and 20 is in the queue, you get 9's children in the queue, no children, 20's children in the queue, 15 and 7 is in the queue. So each iteration kind of is like basically our level. So let's get the current size of the current level. So int size is queue.size. And remember, we have to find the average of this current level. So let's keep track of a sum. Now, these are doubles, and so we don't have to worry about like weird like type conversions later. Let's just make the sum a double. And then what we want to do is we want to consume what I was talking about over here, right? We want to consume every node in the queue. So basically, for int I is equal to 0, I is less than size, I plus plus, just iterating size times. And then all we're going to do is get the current node out of the queue. So queue.pull, just to pull it from the queue or pop it, however you want to say it. And then we want to just add it to the sum, right? So sum plus equals cur.val. And then we also want to add this one's children to the queue. And they'll go to the back of the queue, so we're not going to run into them again. And we're only iterating size times, so that's why this works. That's why BFS works. Let's just make sure that the children are non-null. So if basically cur.left is not equal to null, we can add it to the queue. So queue.add, cur.left. Let's take this, copy it down, and do it for right as well. And like that. And then lastly, we need to add this current level's average to the res. So res.add, and what's an average? It's the sum times the n, or the size. So sum divided by size. We have everything we need. And then, yeah, this is literally it. Let's go ahead and run this. Didn't want to make it too hard. It is an easy problem. And looks like I get incompatible types, tree node. Right, yeah. So I made this int cur. It's actually a tree node cur. So let's go ahead and run this. I was just talking about how it's an easy problem. And I mess it up. Okay, here's the accepted. Let's just go ahead and submit this. And yeah, looks like it's good. 86%, 57%. Now, let's actually talk about time and space complexity, right? So time is very simple. It's just on. The reason being is we're just consuming every node in this tree. We have to visit every single node to find the average. So it'll be on, where n is the number of nodes. Talking about space, this is actually going to be worst case on, because I guess technically, yeah, we're just going to leave it like that because we do have to actually put every node in this queue, even though the res doesn't count as output. It's actually on. Technically, the space is just the size of the biggest level, right? I mean, the most nodes in most level. But, I mean, I'm just going to put on because it's bound to n at least. And then, yeah, hope this made sense. Thank you for watching.